To the playground environment here, you can see it's training the robot, and this is what it's working on. It's going to take a few minutes here. Really, this is just sort of a play environment. There's no actual learning happening based on what I'm doing to the robot. That's a feature the developers have said that they will add later. Um, so you can kind of see as it's learning, it's not very good yet, but we'll come back to it in a few minutes after it's had a chance to figure out how it should work. Um, yeah. So this here is our fully trained Mel. Um, you can see it walking around a little bit. If I can get it to behave, you can see it walk around within the playground environment here. This is just a really fascinating piece of software because it's starting each time from zero and teaching the simulator how to move. I find the gait that it's adopted really interesting, the fact that it's trying this one-footed skip hop. Mostly because that's the gate that my Pygame Walker bipedal simulation also ended up adopting when it was given obstacles to try to overcome. So I find it interesting that the simulators end up adopting a bipedal gait that does not look like human locomotion. So this particular simulation is pretty good. The biggest issue is that because it is a generalized locomotion simulator and not a bipedal walking simulator, it assumes that you want to use all of the limbs that you have given to your creation for walking or for locomotion. And in the case of bipedal locomotion, you only want to use the legs. You want to use the arms for balance, and that requires a different set of reward conditions. I had a nice conversation with the developers about that. The other thing that you can see is happening here is kind of once these fall over, they kind of just throw themselves around on the ground. I had a lot of trouble getting a bipedal robot to stand up at all, and it would just sort of throw itself around on the ground like this. That's because all of the joints are given the same amount of torque. There's no way to adjust that. And so its arms are just as powerful as its legs, and it gives no preference to using the legs. This is something the developers have said they want to work on adding later, that they will add a way to adjust the reinforcement learning rules so that you can reward things like keeping its head and chest up high and keeping its feet on the ground instead of what it does right now, which is just rewarding forward movement to this arrow that's in the playground. I find this particular design to be really good. It's particularly robust. It can keep moving around. And if I can get it to walk over here and show you, no, we fell down. It is able to sometimes, at least, if it doesn't fall over, handle disruptions in its environment, like walking into these big orange balls and pushing them out of the way. So we'll see it go over here, and you can see it just sort of manages to push past and recover. It doesn't instantly fall over when it's presented with a problem. This is a really fascinating piece of software. I think it has a lot of potential. It's not there yet, but it's going to be somewhere. You can see here he's not robust enough to handle the moving floor. But he is capable of moving backwards and all around and turning and things like that. So it's just a really interesting playground to mess around with.